Okay, let's get into it. Welcome to the Deep Dive, where we deliver the crucial context and the technical wisdom you need, all distilled so you can get well-informed fast.
And today, we're all about putting on the safety gear for version control.
Exactly. Our mission is just pure efficiency,
It is. If you're getting ready for a big project, maybe you're joining a new team, or you're just, trying to navigate Git without constantly breaking things.
which is a very common feeling.
It is. This deep dive is basically your shortcut.
Right.
We're going beyond just the basic command tutorials. We're trying to give you the why behind the fix.
Right, turning those common beginner traps into high-level professional habits.
And we're not just talking about minor bugs here. I mean, if you think of Git as this powerful machine managing your whole project's integrity.
Then these mistakes are the critical, completely avoidable failures. They guarantee things like merge conflicts, security breaches, or just a really confusing history.
That's it. We're focusing on 10 fundamental traps. And these trip up everyone, from, the curious learner all the way to the near expert. That project integrity is the central pillar here.
So avoiding these is essential for speed, security,
Yeah.
basically the whole modern DevOps lifecycle.
It's all about scalability and maintainability. That's the end goal of doing version control right.
Okay, so we've broken this down logically. First, how to protect the code base itself.
Then, how to really master the individual commit.
And finally, how to avoid what we're calling team disaster. So let's just jump right in. We have to start where all good development should, and that's security.
Absolutely.
Our first, and I'd argue maybe the most dangerous mistake, is number one, committing sensitive data.
Oh, this one is huge.
I mean, forgetting to use .gitignore and accidentally pushing an API key or a password right into the repository history.
It's a catastrophic risk, and it happens way too often.
Yeah.
And the real problem is, even if you delete the file in the very next commit.
It's too late, right? The history's there.
Exactly. Git's whole purpose is to track history. So that secret is now, permanently embedded. Anyone who can walk through that history can find it.
And a lot of platforms now have secret detection to catch this stuff, but that's after the fact.
Right. Prevention is the only real defense here.
So, okay, that panic moment hits. You've spotted the secret in the history. What is the immediate, non-negotiable fix?
It's a two-step sequence. First, you have to stop Git from tracking the file going forward, but, and this is key, without deleting it from your actual computer.
Okay, so what's the command for that?
It's git arm cached and then the file name. That pulls the file out of Git's index.
And step two?
Mandatory step 2 is to immediately add that file name, or the whole directory, to your .gitignore file. Then commit that .gitignore change.
So stop tracking, then prevent future tracking. That makes sense. But what about getting it out of the past history? Is there a quick fix for that?
Not really a quick one. For a professional team, you need an advanced tool, something like BFG Repo Cleaner, to completely scrub that data from every previous commit, but that's a whole operation.
It sounds like a deep cleanup that needs team coordination.
For sure. The immediate fix we just gave, though, that ensures the secret doesn't spread any further in new pushes.
Okay, so once the secrets are safe, we protect the process. This next one is huge. Mistake 3. Working directly on the main branch. Why is that such a basic violation?
Well, it really just violates the core idea of modern team development, what people often call GitLab flow, or a feature branch workflow.
I like the analogy of the main branch as this stable, deployed highway.
That's a perfect way to think about it. And feature branches are the safe, separate roads where you actually do the construction.
So if I start building my new feature directly on the highway,
You're causing a massive traffic jam. You're blocking everyone else. You can't get a proper peer review on your specific changes. And worse, every time someone else pushes a small fix, you immediately get merge conflicts.
because my half-finished work is tangled up with their stable code.
Exactly. It just kills any chance of scalable team development.
Okay, so I'm halfway through, and I have that oh no moment. I realize I never made a branch. What's the ripcord?
Pull it immediately. Just use the command git checkout -b and then your new branch name.
And what does that do?
It takes all your current work, preserves it, and instantly moves you and all your changes onto a brand new isolated branch. You've just moved your construction zone off the highway and you're ready for a proper merge request.
That's a lifesaver.
Before we move on from setup, can we quickly clear up one other thing?
Please.
It's mistake 9, misunderstanding fork versus clone. This is just pure setup confusion for a lot of people.
Yeah, early on, I definitely thought there were just two ways to get the code. Can you give us the key difference, especially in a system like GitLab?
Absolutely. When you use git clone, you're just making a local copy of the repository on your machine. You clone when you already have write access or you just want to look at the code locally.
So clone is for my own machine.
Right. A fork, on the other hand, is a server-side thing. It creates a copy of the entire project under your own name on GitLab or GitHub.
And why would I do that?
You fork when you don't have write access to the original project, but you want to contribute. You make your changes locally, push them up to your fork, and then you propose that change back to the original project.
And that proposal is the merge request.
That's the merge request. So forking is for contributing to external projects. Cloning is for your local work.
That actually leads us perfectly into mastering the commit itself.
Yeah.
If the process is set up right, the next step is perfecting what you're actually creating.
Right. This is all about quality, size, and clarity. High-quality commits are the building blocks of good software. They're your contract with the team and, your future self.
And the first step toward a messy contract is mistake 2, the add-all trap. That sweeping, almost lazy use of git add without even thinking.
I call it the clutter commit problem. It's when you just scoop up everything, temp files, logs, IDE settings, things you forgot about.
All in one commit. You think you're being fast.
But you're really just adding junk to the project history.
And I can hear the pro tip coming. You have to check Git status. It's the most basic safety check there is.
It is the first commandment of Git. See what Git sees, then add only what's needed for that one specific logical change.
And for someone who wants to level up,
Skip the sweeping add completely. Start using git add-p, that's patch mode. It lets you review and stage specific parts of files.
so your commit is surgically precise.
Exactly. It prevents the clutter before it even starts.
Okay, so you've staged the right files. Now we hit mistake 4. Vague commit messages. Things like fix bug or minor update.
Those are the worst.
I'm so guilty of this when I'm in a rush. It feels like such a tiny detail, but it has these huge ripple effects.
It's a massive review killer. It's like reading a technical paper titled Information. It tells you nothing. If your reviewer has to guess the context, guess the scope, guess the why,
Yeah.
you're just slowing everything down.
So a good commit message should really tell the whole story.
Or at least the intent and scope. It saves so much time.
Okay, here's the fix. You just made a terrible commit message, but you haven't pushed yet. What's the command to rewrite it locally?
You use the very powerful git commit amend.
Amend. Yep.
It takes your most recent commit, lets you completely rewrite the message, and then it replaces the old commit with your new corrected one. It's your local time machine for commit messages.
Building on that, let's talk about mistake 6. Giant commits, the bundle problem.
Ah, yes.
Bundling 5 totally unrelated things, a style change, a doc update, 2 new features, into one massive commit.
It's like wrapping a 5-course meal into one big weird ball. It feels efficient because you only type git commit once, but the technical debt is immediate. The biggest pain point is trying to debug or revert that commit.
Wait, why is reverting so hard? Can't you just undo it?
Well, you can, but if a bug is traced back to that giant commit, using git revert undoes all 5 of those unrelated changes.
So you fixed the bug, but you also just erased the new features you wanted to keep.
Exactly. You've just traded 2 minutes of effort now for hours of painful cleanup later. The solution is simple. Commit frequently, commit atomically. One logical change, one commit.
Okay, time to talk team interaction. This is where your local mistake becomes everyone's global headache.
This is where synchronization is everything.
And the #1 sync issue is mistake 5, forgetting to pull before pushing. You finish your awesome feature, you hit git push, and reject it.
The server just tells you you're out of sync. It creates so much avoidable friction. Now you have to deal with merge conflicts because while you were working, someone else already pushed their changes.
In the default, a simple git pull creates a merge commit, right?
Yeah, and that merge commit just clutters up the history. Its only job is to say, hey, I merged 2 different histories. It doesn't add any real value.
So this is where the pro tip comes in. Instead of a basic pull, you recommend git pull rebase. Why is that better?
Because it gives you a clean, linear history. A rebase basically takes your local commits, sets them aside for a moment, pulls down the remote changes, and then replays your commits right on top of the new history.
So it looks like my changes happened after everyone else's.
In a perfect straight line, it's so much easier to read, to revert, to audit. It's just good history housekeeping.
But hold on, if rebase rewrites history, isn't that really dangerous?
That is an excellent point. It is rewriting history, but it's only moving your personal commits that you haven't shared yet, so it's perfectly safe before you push.
So the rule is, Never rebase history that other people have already pulled.
You got it. But for cleaning up your own work locally before a push, rebase is the mark of a considerate developer.
Speaking of rewriting history, let's talk about the single most dangerous error. Mistake 7. Force pushing to shared branches.
The dreaded git push force.
Yeah, this is where we need the dramatic music. Why is this considered so deadly in a team setting?
Because it is an atomic bomb for collaboration. When you force push, you are literally overriding the remote repository's history with whatever you have on your machine.
So if my teammate just pulled the branch 5 minutes ago.
And you force push, you have just destroyed the history their local copy is based on. Their next git pull will fail, maybe catastrophically. They could lose hours of work.
So the rule is just never.
Never, ever use force push on main, master, or any branch other people are actively using. Full stop.
Okay, finally, let's hit mistake 10. Ignoring the merge request description. This feels like a soft skill, but it has real technical consequences.
It absolutely does. When you submit an MR with just the default title, you're putting a massive unnecessary burden on your reviewer.
The context gap.
Exactly. A good MR description should summarize the what, the why, and maybe the how you tested it. Otherwise, reviewers have to dive into the code blind, just guessing your intent.
Was this a performance fix?
Oh.
A security patch? A UI tweak?
All that guesswork just slows down the review, delays the merge, and ultimately impacts how fast you can deploy. Thorough documentation in an MR is professional documentation. It speeds up the entire life cycle.
We've covered the big pitfalls in workflow, but what about those pure panic moments? The times when you think you've just, irreversibly broken everything.
Yeah, let's talk about mistake 8, the detached head state.
The name alone sounds like a horror movie.
It really does. It sounds so scary.
So what is actually happening when you use git checkout on a specific commit hash, a moment in time, instead of on a branch name?
The concept is actually pretty simple. Imagine your branch's main, feature A, are named hiking trails. The head pointer is a little signpost that shows where you are.
Okay.
Normally, that signpost is bolted to the end of a named trail. When you make a new commit, the trail gets longer and the signpost moves with it.
Right.
When you check out a specific commit hash, you've basically stepped off the trail and you're just standing in the middle of the woods. The signpost, head, is detached from any branch name.
And the danger there is?
What? The danger is if you start making new commits, they're just floating. They aren't on any branch. If you then check out another branch, those floating commits can be lost forever when Git does its garbage collection.
So how do I fix it if I'm in that state?
The immediate fix is git branch and then a new branch name. You've just created a new trail right where you're standing, and all your work is saved.
That makes so much sense.
Yeah.
Okay, that brings us to the final essential pro tip. When you feel like you have completely lost control or you've accidentally deleted something important, what is the ultimate safety net?
This is the tool that separates the panicked beginner from the confident pro. The git reflog.
Not the log, the reflog.
Correct. You have two lifelines. Git log shows your committed history, but git reflog is the secret audit trail. It shows every single thing you have done in your local repo.
Every single thing.
Every commit, every merge, every rebase, every checkout, even commits that were deleted or were on a detached head. It's a log of where head has been.
So if I accidentally delete a branch,
you look at the reflog, you find the hash of the commit right before you broke things, and you can use git checkout to get right back to that state. It is the ultimate undo button.
And what about the simplest case? I just deleted a file I haven't even committed yet.
Easiest fix in the book. If you accidentally deleted or changed an unstaged file, the command is git checkout and then the file name. It just discards your local changes and restores the file from the last commit.
An immediate reset button.
And that's pretty much the full inventory. We've hit on sensitive data, team workflows, commit quality, all with the precise commands you need to, move forward without the stress.
And the big takeaway for me is that the biggest wins come from these small, disciplined habits.
Exactly.
Like checking Git status every single time, committing atomically, or remembering to use pull rebase.
Those habits prevent 99% of the complex troubleshooting that just causes burnout. It's how you gain knowledge quickly and actually apply it.
Right. And you mentioned earlier that security systems often catch secrets even after they've been committed, because that history is largely immutable. It's just there.
It is. Unless you do that deep advanced scrubbing we talked about, it's embedded. And that raises a really interesting question for a thoughtful engineer about history itself.
Here's where it gets really interesting.
Yes. So, beyond the obvious dangers like API keys and passwords, what other seemingly harmless information in past commits should an engineer be aware of?
What are you thinking of?
Things like internal ticket numbers, maybe temporary file paths that accidentally expose your server structure, or even developer names and code comments. All of that is now permanent, auditable data, especially in a public repository. The code history becomes its own intelligence stream.
So it forces you to consider the permanence of every single keystroke.
Exactly. It's something to mull over as you start integrating these new commands into your daily workflow.